So let's examine the velocity and acceleration sign analysis so that we can actually think about what's going on in this time frame. All right. So what I'm going to do is I'm going to draw a number line, and we're going to set up a sign analysis here. So we're going to set up velocity above this and acceleration below. All right. So we're going to start at 0, A, B, C, and D, right? All right, so now velocity, remember, was 0 at A and C. All right, and then where is acceleration 0? Well, it so happens that it's 0 at B. All right, so now let's think velocity. All right, it is positive from 0 to A, and it is negative from A to C. So remember, we should draw in our intervals. I'm sorry. All right, and then it is positive once again from C to D. All right, now what about acceleration? Well, remember, this curve is concave down, right? We already wrote this over here. So it is negative from 0 to B, and then it is positive from B to D. All right, so now I want you to think. From 0 to A, velocity is positive and acceleration is negative. So what does that mean? Velocity is increasing. Excuse me. Velocity is positive and decreasing, right? So if you think about it, if velocity is positive, but it is decreasing, that means the velocity is moving towards 0. So that means we must be slowing down. All right. And so then think about from A to B. Velocity is negative and acceleration is negative, which means acceleration is negative. So velocity is decreasing. So velocity is negative and decreasing. So that means what? A negative velocity that's decreasing is moving away from 0, which means it is speeding up. Speed must be increasing if a negative velocity is decreasing. All right. Next, from B to C, velocity is negative, but acceleration is positive, which means velocity is increasing. But an increasing velocity that is negative is moving towards 0, which means that the object is slowing down. And then from C to D, the velocity is positive and the acceleration is positive. So what does that mean? The velocity is the velocity is positive and increasing. So if velocity is positive and it's increasing, it's moving away from 0, therefore it is speeding up. All right, so can we generalize? All right, what's going on in each one of these intervals? Well, the fact is that in the first interval and the third interval, the signs of velocity and acceleration are opposite. Therefore, we are slowing down. And in the second interval and the fourth interval, the signs of velocity and acceleration are the same. Therefore, we are speeding up. So generalize for yourself. Speeding up when V and A have the same sign. Okay, so that's speeding up. Slowing down when V and A have opposite signs. All right, so that is an important generalization that we need to understand. All right, so that's section 5.2, position, velocity, acceleration. So let's do some examples. All right, so on to slide number 8. An object moves along a horizontal number line so that its position at t seconds is s of t equals t cubed minus 6t squared plus 9t plus 1. When is the object moving to the right? So what would moving to the right mean? All right. Excuse me. So moving to the right would mean that position is increasing, or we could say velocity, v of t, is greater than 0. All right, so first of all, we need to find velocity. So v of t, or remember, v of t is s prime of t. So very simple, 3t squared minus 12t plus 9, right? So that's s of t. So now, if I want to know when velocity is positive, I first of all need to know when it is 0, and then we can do a sign analysis. So we're going to set s prime or v equal to 0. So 3t squared minus 12t plus 9. So I'm going to start by factoring out 3. So t squared minus 4t plus 3. And so I can divide by 3, which makes that value not relevant for when this equals 0. And then I'm going to factor. So this factors into t minus 3 and t minus 1. All right, so t equals 3 and t equals 1. Now, I know the question doesn't necessarily ask it, but what have we just figured out? We have just figured out that the velocity equals 0 at t equals 3 and t equals 1. So velocity equaling 0 means what? Object has stopped momentarily, right? At t equals 1 and 3. All right, so now, if it has stopped momentarily, then that means it could potentially be turning around. All right, so now what we want to do is we want to do our sign analysis. So I'm going to put 1 and 3 on my number line. All right, and I have the 3 in front, so I shouldn't lose that. So 3t minus 3 and t minus 1. All right, so now 2 rows, top row 0 above 3, bottom row 0 above 1. All right, and so pick a number to the left of 3. How about 0? 3 times 0 minus 3 is a negative. Pick a number to the right like 4. 3 times 4 minus 3 is positive. All right, bottom row, pick a number to the left of 1 like 0. 0 minus 1 is negative. How about 2? 2 minus 1 is positive. Right, so velocity is positive, then negative, then positive. So when is the object moving to the right? Well, to the left of 1 and to the right of 3. All right, so I didn't give you a domain here, but let's just say our domain is like 0 to 6 or something. So when would the object be traveling to the right? Okay, so object moves right on the interval 0 to 1 and 3 to 6. How about? All right. So remember, we don't want to include the endpoints here because we don't want to say it's moving to the right at 1. So we wouldn't put a bracket there because, well, it has stopped at 1, right? And it has momentarily stopped at 3. So we shouldn't include those. All right. So now we want to draw a motion diagram, right? So remember, okay, we're going to draw this like number line. Remember, it says the object is moving along a horizontal number line. So what we want to do is we want to say, okay, here is my starting location, right? My starting location is right there, okay? And we'll come back to that in just a moment, all right? But down here, okay, this is at t equals 0, right? That's the starting time. So now it says I travel right from 0 to 1. So I'm going to put a little arrow here, and then I'm going to go to t equals 1, and I have traveled to the right. Then I stop, turn around, and travel to the left. So now I'm traveling to the left, all right, until I get to t equals 3. Okay, now the problem is that I don't know how far to the left I have actually traveled. So let's take a second here. Okay, this is actually kind of like the critical number test. Where did I start? So I actually want to know my position at 0. So 0 cubed minus 6 times 0 plus 0 is 1. So that means I started at a position of 1. Okay, now I traveled to the right. Well, how far to the right did I get? So now I actually want to know S of 1. So I would plug in 1 cubed minus 6 times 1 squared plus 9 times 1 plus 1. So 1 cubed minus 6, negative 5 plus 9 is 4, plus 1 is 5. So I actually got as far to the right as 5. Okay, now I traveled to the left. Well, how far to the left did I get? Well, then I need to know S of 3, right? And so 3 cubed minus 6 times 3 squared, right, plus 9 times 3 plus 1. All right, 3 cubed. 3 times 3 times 3 is 27 minus 6 times 3 squared. 3 squared is 9 times 6 is 54 plus 9 times 3, 27 plus 1. So 27 plus 27 is actually 54. Minus 54 is 0 plus 1. So I actually just got back to my origin, right? So I got back to 1. Now, it's also possible that I went past it or that I didn't get all the way back and I stopped somewhere over here. But I did get back to 1 according to my work here. And so then I can say, okay, at t equals 3, now what happened? I stopped, turned around, and started traveling back to the right. Well, then I went until 6, but how far did I get? Well, at 6, I would have to know. So 6 cubed minus 6 times 6 squared plus 9 times 6 plus 1. So 6 cubed, well, 6 cubed, I don't know off the top of my head, but I do know that 6 times 6 squared is also 6 cubed, so those subtract out, plus 9 times 6, so 54 plus 1 is 55. So that means I kept going until I got as far right as 55, and that's where I ended at t equals 6. So do you understand how this is really just the critical number test, but it's really helping me to understand the motion of the object and actually how far right and left I actually traveled. Okay, so that's a motion diagram. All right, but now let's continue on to slide number 9. All right, so slide number 9. An object moves along a horizontal number line. So same equation. When is the acceleration negative? All right, so remember, acceleration is the derivative of velocity, and velocity is the derivative of position. So I need to figure out when acceleration is less than 0. So I need to find acceleration. All right, so remember, acceleration is equal to v prime of t, which is equal to s double prime of t. So really, all I need to do is take the derivative of the velocity that I had earlier. So velocity was 3t squared minus 12t plus 9. And so now I take the derivative of that. So I get 3 times 2, 6t minus 12. And I wrote 9, but I said 6. 6t minus 12. All right, so now how do I know, how do I figure out when acceleration is negative? Well, the first thing I need to do is I need to figure out when acceleration is 0. So acceleration is 0 when 6t minus 12 equals 0. So I add 12, divide by 6, so t equals 2. So now I want to do a sign analysis on acceleration. So remember, I only have the one factor, 6t minus 12. So that is 0 at 2. So a number to the left like 0, 6 times 0 minus 12 is negative, and a number to the right like 3, 6 times 3 is 18, minus 12 is positive. So when is the acceleration negative? Well, the acceleration is negative on the interval 0 to 2. All right, so now it says, what is the velocity when acceleration is 0? So all this is really just, what is v of 2? Right? That's all it's really asking. So what is v of 2? So I go back to my v equation, 3 times 2 squared minus 12 times 2 plus 9. All right, so 3 times 2 squared, right? Well, 3 times 2 squared is 12, right? So 3 times 4 is 12, minus 12 times 2, so that's 12 minus 24 is negative 12, plus 9 is negative 3. So that's it. All right, what is the speed when acceleration is 0? So now I'm looking for the absolute value of v of 2. So very simple, that's just 3, right? Just making sure that we understand that. All right. So now, keep moving on to slide number 10. Draw a graph of s of t on the interval 0 to 6. Well, really, that's not that big of a deal because we actually already did all the work, right? So here's s of t, right? Here is t. What did we already do? Well, we know that we started at 0, sorry, not 0, 0, 0, 1, right? Because we already did that work. Then we traveled forward until we got to s equals 5, right? Then we traveled backwards, and then at t equals 3, we stopped and turned around, and then until 6, we traveled forward again, and then we got to 55, right? Now, how about the curves? Well, obviously, we could match up our double sign analysis, right? So on our number line, we have 0, 0, we have 6 here, and then we had 1, 2, and 3. So if I put my v up here and my a down here. All right, so remember, velocity was 0 at 1 and 3, and acceleration was 0 at 2. Right, so we have these intervals. All right, so now our velocity was positive, right, then negative, then positive, and then our acceleration was negative, then positive. All right. So now, if we look at it, we have an increasing concave down curve, which is what we drew from 0 to 1. Then we have a decreasing concave down curve, which is what we drew from 1 to 2. And then we have a decreasing concave up curve, which is what I drew from 2 to 3. And then we have an increasing concave up curve from 3 to 6, right? So, yeah, maybe I kind of knew that, but we could take our double sign analysis and then go back over here. And remember, we already did the critical number test, so we knew the y values. All right, but now that double sign analysis makes number 7 really easy. When is the object speeding up? So what did we say? Speeding up means that velocity and acceleration have the same sign. So speeding up from 1 to 2 and from 3 to 6. Slowing down Well, slowing down when velocity and acceleration have opposite signs. So from 0 to 1 and from 2 to 3. Okay, now, another thing to remember, okay, you must slow down before you stop. When did we stop? Well, we stopped at 1. So you must have slowed down before you got to 1, right? We also stopped at 3. So you must have slowed down before you got to 3. Okay? Now, if we stopped, how could we start moving again? Well, we must speed up after we stop. So from 1 to 2, we were speeding up, right? Because we stopped at 1, and then we stopped at 3, so we must be speeding up again after that from 3 to 6. So you can definitely keep those things in mind. All right. But anyway, that is section 5.2 notes.